So for the Josephus queries, the question is you are given n, that is representing the number of children and who are in a circle. And during the game, every second child is getting removed until there are no children left. And you have to process q queries, and each query will be containing two integers n and k, where n is the total number of children and k is the the, nu- the child who would be removed. Like we need to return the kth child that would be removed. So if I take the query that is 7 ones, let me paint it. So this 1, 2, 3, 4, 5, 6, and 7. So in the first turn, 2 would be removed because every second child is getting removed. Then again the second child is 4. Then 1, 2, 6 would be removed. Then 1 would be removed. And so on and so forth. So the first child who would be removed is 2. So we can see the first child is 2. Then who would be the third child? I painted it like the third child is 6. So I think the question is clear now. So we can move with the one more example that I have created for a better understanding of the algorithm. The example that I prepared for the two cases, even and odd. So for the case of even, in the first turn, the children that would be removed is 2, 4, 6 and 8, and I'll be left with 1, 3, 5 and 7. If I consider the initial case of 4 children, what it would be? 1, 2, 3 and 4. Can you relate this? 1, 1, 2, 3, 3, 5, 4, 7. I think it's a basic equation, that is 2n minus 1. If I consider the odd case, it's similar, 1, 2, 3, 4. That is basically 2n plus 1 for the odd case. Like 1 is representing 3, that is 2 into 1 plus 1. So it's for the odd case and it's for the even thing. Like if our k is less than n plus 1 by 2, because for the even case the number of children that I could remove is 1, 2, 3, 4. But for the odd case, if I have 9 children, then I can remove the number of children is 5. So it's n plus 1 by 2 children that I could remove. And if k is less than equals to n plus 1 by 2, then I could simply return my answer as 2 into k. Because if k is 1, then it's 2. If k is 2, 4, then 6, then 8. It's 2 into k. But for the odd case, if k is 5, then 2 into k is 10. That is greater than n. So we have to modulo with n. If 2 into k is exceeding n, that our answer could not be greater than n, so we need to modulo it with n. If it is greater, else we don't have to modulo. So I think this is clear. If I'm returning 1, then we have to assume it's 2n minus 1 from our original position. If I'm assuming I have 4 children, then if I'm returning 1 as my answer, then it should be treated as 2n minus 1 in the case of even. If it is odd, if I'm returning 1, then it should be treated as 2n plus 1. That's my answer is 3 as for our initial case. So let's discuss the code now. So if I am just taking the input over, if n is 1, I have no only one child left, then I need to simply return 1, no answer left. And we have to check, like, if k is less than n plus 1 by 2, then I'm checking if 2 into k is exceeding n. If it is, then I need to modulate with n. If not, then I can simply return 2 into k. Then again I'm calling the function every time n is getting reduced by 2. We can see that 8 got reduced to 4 and 9 got reduced to 4 again. So 9 by 2, 8 by 2. For even and odd cases, both are same, it's n by 2. Again, I'm doing k minus n plus 1 by 2. That is, k is getting reduced. Because for the first term, we have already removed 2, 4, 6, 8. That is, k is getting reduced by n plus 1 by 2. For odd is 5, for even it's 4. So k is getting reduced. And then again I am checking if it is odd, then I need to consider it as 2 into 10 plus 1. Else I can consider for the even case 2 into 10 minus 1 that I have said. Because if I'm returning 1, then you have to consider it's 2 into, if it is even, then 2 into 10 plus 1. 1 is 2 into 1 minus 1. That 1 should be considered 1 only. But if I am returning, for this case, I'd be returning 1 only. But that's the case of, I think it's odd. No, it's even. So it's could be considered as 1 over here also. Over here also. But here it would be considered as 3. Because I have odd number of n's. And if you are returning 1, 1, 1, 1, because I have odd, even over here 1, 2, 3, 4, again even over here. So 1 would be 2 into 1 minus 1. 1 would be same. But here I have odd. And it actually was 3 only. So if I'm returning 1, then I have 2. So this time of function call would be considered this result as 1 only. Then this function would be considered as same 1, but as my final answer would be 3, because I have odd number of children. So it would be 2 into 1 plus 1, 3. And originally it was 3. Yeah. So we got our answer. So we have to take care of even and odd conditions. So that's it, and you'll get your answer. So that's it for the video. Thank you for watching.